Hi Year 11 and welcome to another exciting trigonometry class. Today we're going to be reviewing the sine rule, which was covered in Year 10, so let's get into it. First of all, when do we use the sine rule? Remember, it's for when we're doing questions involving triangles that are not right angled, and we need two angles and one side length. When you know two angles in any triangle, you can figure out the third one because you know all three angles add to 180, or you know two side lengths and you have to know an angle that's opposite one of those side lengths. So let's just revise our sine rule. So remember, capital letters correspond to angles. So we can just assign the three angles, capital A, capital B, and capital C. Then we can assign our side lengths, and remember, opposite capital A is side length lowercase a. Opposite capital B, side length lowercase b. Opposite capital C, side length lowercase c. So, hopefully you can remember this rule from last year. This is the rule as written when we want to find a side length, because the side lengths are in the numerator. If we're trying to find an angle, we use the same rule, but it's flipped upside down. Remember, we're dealing with opposites. Now, A over sine A, which in this case would involve this section, B over sine B, this section, C over sine C, this section. We're not going to use all three of them. We'll normally only use two out of the three of them. Let's try our first example. So, we've got a triangle ABC, little a, little c we're given, capital C we're given. Find two possible values of angle A and two possible values of angle B and little b. That doesn't make sense. Let's ignore that bit for the moment. Let's just get a diagram. Well, let's label randomly our A, B's and C's, and notice the A's opposite, the B opposite, the little c is opposite capital C. So we've got our capitals for angles, our lowercase letters for side lengths. What do we know? Well, we know little a, little c and capital C, so let's put that in. Now, if we were to look at what's going on here, you'll notice my shaded green section. The C's, I know angle C and side length C, so I know both those pieces of information. Not interested in this section because I don't know little b or capital B. I do know little a. I'm going to find angle A first. So we use the sine rule. And if I'm finding an angle, I put the sine of the angle on top. Notice I didn't use B, I used A and C, because I don't know any lengths for B or angles for B. So, put in what we know. We know little a, little c and capital C, times both sides by 10. Now I could actually calculate that on my calculator, but I know I want to find angle A, so I'm going to take the inverse sine of all of that, put that into the calculator, and the angle works out to be about 56.4 degrees if I round it to one decimal place. So, we now know 2 out of our 3 angles in the triangle. Well, how do you find the third angle? We know that in triangles, 3 angles add to 180 degrees. So if my 3 angles add to 180 degrees, let's put down the angles that I do know. I know angle A and angle C. Add the 56.4 and the 30 together, that gives me 86.4. Subtract 86.4 from both sides, and I now have my value for angle B. All that's left now is to find side length B. Well, I'm going to use the sine rule again, but this time I'm going to, because I'm looking for side length B, I'll have side length B over the sine of the angle opposite that, equals. Now I could use A over sine A or C over sine C, but I'm using the C because when I found angle capital A, there was a little bit of round off, and I just want to avoid the round off. So let's put in what I do know. I know angle capital B, I know angle capital C, and I know side length little c. Putting that in, I'm going to multiply both sides by the sine of 93.6. Calculator says to one decimal place, little b is 12 meters. So I now have my 3 side lengths and my 3 angles for this triangle. But let's just reread what the question said. It said find 2 possible values of A. Now, what is that talking about? 99% of the time, you'll never have to worry about this. But what we need to understand is that when you deal with the sine rule and you are finding an angle, sometimes there are two cases. There is a normal case and an ambiguous case, and the sine rule will always find an angle that is acute. So it's less than 90 degrees. If our answer was more than 90 degrees, it was obtuse, we have to do that little bit of work manually. We can't rely on the formula. So let's just examine our question. Remember, we were told we had a side of 10 meters, another side of 6 meters, and an angle of 30 degrees from my original diagram when I labeled it. But what would happen if I had a side of 10 meters, an angle of 30 degrees, and my 6 meter length went on a slightly different angle, but it's still 6 meters long? I would actually have two triangles that satisfy my question. Now let's just have a look at this for a second. There's two triangles that exist. We only found one of them when I used the sine rule. How are we going to find the other answer? Remember, when I used the sine rule, the first thing I did was found this angle up here, and it was 56.4. If I look at this case here, yeah, that could be my 56.4 because it's obtuse. But when I look at my second scenario, there's no way that's 56. It's bigger than 90 degrees. It's an obtuse angle. So if you're ever trying to find an obtuse angle, well, we're going to do everything the same except we have one extra bit that we have to do manually. So let's start this question all over again. Let's deal with the ambiguous case and pretend that we were looking at it from the first time. So here's my triangle. I've labelled the sides that I know. 10, 6, and 30 degrees is the angle I know. Let's find angle A. So this is exactly what we did before, 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 and we've got the same angle. But now I'm going to say, what if that angle was more than 90 degrees? Because you can have triangles that are obtuse. Well, if you're finding an obtuse angle, you just take the angle the calculator found here and imagine that as being a reference angle in the second quadrant. So what we actually do is 180 minus 56.4, and that tells us that that angle could also be, in the ambiguous case, 123.6 degrees, and then we proceed as normal. An angle in here that says 123.6 degrees now. So how do I find angle B? Well, the three angles add to 180. So my angle A is now 123.6. Add that to my 30, I get 153.6. Subtract that to both sides. This angle down here is 26.4 degrees. Now that I know all four angles, let's find our missing side length, little b. It'll be b over the sine of angle B. Equals c over sine 30, as we had before, times both sides by the sine of 26.4, and we get 5.3 degrees. That's for the ambiguous case. So there's two possible triangles that we could have ended up with. So here's our question. The normal case, they're the answers that we found. The ambiguous case, they're the answers that we found. The difference is, when we look at it closely, our angle A, when we found using the sine rule, was 56.4. It is possible that angle could have been 123.6, and 56.4 and 123.6 both add to give the 180 degrees. So your calculator will always give you the smaller angle. If it says find an obtuse angle, you just take that angle away from 180, and then you're dealing with the ambiguous case where you're finding the obtuse angle. So don't worry about this subtracting from 180 unless it asks you to find the obtuse angle. All right, here's another example. This is not in your notes. So just watch this one, see what happens. To calculate the height of a building, Kevin measures the angle of elevation to the top as 52 degrees. He then walks closer and measures the angle of elevation as 60 degrees. How high is the building? So let's draw a bit of a picture. Let's have a look. He's looking and it's 52 degrees to the top of the building. Then he moves 20 meters closer, and when he looks, it's 60 degrees to the top of the building. So he needs to find out how high the building is. Well, when you get a question like this, we need to first of all find all the angles that we can. Now let's think about the triangle I've marked with blue. I can find this angle here because there's a straight line going across here. If that's 60 and I know a straight line is 180 degrees, that means that angle in there is 120. And if that's 120, and that's 52, and I know three angles inside a triangle add up to 180, means that angle up there is 8 degrees. So now I could find this side length here using the sine rule, and I'm going to call this side y. It's just randomly chosen. Y over the sine of the opposite angle equals 20 over the sine of the opposite angle. So we get y over sine 52 equals 20 over sine 8 times both sides by sine 52, and we find y is about 113.24 meters if we go to 2 decimal places. So let's put that there, and now consider the triangle I've highlighted in green. We know an angle. We know the hypotenuse. Because this is a right angle triangle, we can find x using SOHCAHTOA. This is a sine question, so sine 60 will equal x over 113.24. Multiply both sides by 113.24 and we find x. So it's just a different style of question that you come across. Well, time for you to get into it. Enjoy the experience. Bye for now.